Good morning and welcome to Wednesday of week 3 of your Physics 5 a day, and today we're starting waves. Waves are oscillations that travel. In transverse waves, the oscillations are perpendicular to the direction the wave is travelling, and in longitudinal waves, the oscillations are parallel to the direction the wave is travelling. Waves transfer energy in the direction they're travelling, but they don't transfer matter. And we can show this with a slinky spring. So imagine this is my slinky spring here. And I'm going to tie a little bit of coloured thread or put a blob of paint or something like that on the middle of my slinky spring. And we're going to look and see what happens to that blob of paint. So I'm going to move my hand forwards and backwards to send a longitudinal wave along the slinky. What's going to happen to the blob of paint? It's not going to go that way, it's not going to travel off that way, it's just going to oscillate backwards and forwards. And now let's try a transverse wave. This time I'm going to move my hand left to right to send a transverse wave along my slinky spring. And once again, the energy is being sent off that way, away from my hand, but the blob of paint is going to be moving left to right. And this again shows that while the energy is moving in the direction of travel, the matter isn't. The actual atoms of the slinky spring, they're just oscillating. Okay, these waves we've drawn here are progressive waves. And as you know, another thing you can do with waves is that you can reflect them and trap them between two places. So here's my progressive transverse wave being created here and just being sent out to infinity. And here it is again, but this time it's going to be reflected here and go backwards, and then reflected here and go backwards. And so I'm trapping the wave between these 2 points. Here's a longitudinal version. So here's my slinky spring again. I'm sending a progressive longitudinal wave out to infinity. And here's a version with sound where I'm creating my longitudinal wave here. It's going down to the bottom of the cylinder, reflects, comes back up, reflects, and so I'm trapping it in here. Now remember, if the length of the bit you're trapping the wave in is just right, then you get very nice, tidy, pretty patterns. But we'll talk about that a lot more in the stationary waves video. For now, let's compare progressive and stationary waves. So as we've already said, progressive waves transfer energy along the direction of travel, but stationary waves don't, because you've trapped the wave and so they actually store energy in here. And for progressive waves, every point on the wave has the full range of motion. So if we imagine our blob of paint again on the slinky spring, so the blob of paint is going to go all the way to the peak and all the way to the trough and so on as the wave goes past it. Whereas on a stationary wave, let's say my blob of paint was here, well here it's only going to go up as far as that and down as far as that and up as far as that and down as far as that again. So it's not going to have the full range of motion. A blob of paint here will. A blob of paint here is going to go all the way to the top and all the way back to the bottom again. A blob of paint there isn't going to go anywhere. So on a stationary wave, the parts of the slinky spring only have some of them only have limited motion.